Today we're going to be looking at some of the important aspects of analysis for IR. So this is a basic IR spectrum. So remember that the x-axis is about energy and the units are wave numbers. This is a representation of frequency, so frequency can relate to energy. The important parts of an IR spectrum are the absorptions. Now, depending on how you've spoken about this in the past or what you've read or what you've looked at online, sometimes these are all called peaks. I tend not to call them peaks because the baseline is at the top of the spectrum. And then the absorption of the infrared laser is represented by the dip of that baseline. So the more absorption you have, the lower the absorption is going to be. So in this case, if we look at this one right here, these are pretty strong absorptions, and these are pretty weak absorptions. Now, we only need to concern ourselves with everything to the left of this imaginary line. So this down here is called the fingerprint region. You can do analysis in the fingerprint region, but it is pretty difficult because there are a lot of different kinds of absorptions that happen. We deal mostly with stretches, and the stretches come in between 1500 and 4000. Everything below 1500 is often asymmetric stretches and bends and scissors and other things. So we sort of leave that for more advanced analysis in other courses and for the professionals. So what we're going to do next is look at individual absorptions. When you're analyzing an IR spectrum, it's important to have a table of IR absorptions next to you. Now, these are easy to find. You can either look at an old textbook, you can look at an online source, or some of the things that we've handed out in this class. But it's always useful to have that reference to you. We will never ask you to do analysis without that reference. So in a class like this, you're always going to have that available, particularly because this is an online class. But for me, even when I teach in semester, I always give my students an IR reference table. So what you want to do, if you're not given a table of exact data or you don't have the peaks marked, that's okay. What you want to do is get an approximate wave number for each of these important absorptions. You don't need to necessarily draw a line down to the x-axis, but you can if you wish. So then you can correlate the absorptions that you see with a table, and that will give you the type of bond that gives that absorption. So for instance, we have approximately 3300 here. This is an OH. Whether it's an alcohol or phenol, that's an OH. Anything that is below 3000 here is an sp3 hybridized CH. This one here, because it is above 3000, is an sp2 hybridized CH. So this is greater than 3000. And you can see that differentiation for the different kinds of carbon-hydrogen bonds. The alkyne CH is actually a little bit higher wave number than that. You'll notice I have this peak marked here, but there's nothing that shows up in this particular area. So it doesn't correspond, this sort of 1800 to 1900 region. There's no known absorptions that show up in that particular area. So we can eliminate that. We have something that's probably in the 1600s. And let me erase this rather large thing right here. So 1600 wave numbers, this is most likely going to be some kind of carbon-carbon double bond. So that's sort of the basics of how I would go through an analysis. It's for us in the lab right now, it's more important to worry about the analysis than the fundamental nature of IR, since we're sort of applying it to the experiments that we're doing. So I'm much less concerned about the background than actually applying. So in a different video, I'm going to show you a homework assignment that I give my students during the semester with a table that you can fill in. So check that one out later.